So nowadays, most of our systems consist of single-stage transistor, which doesn't provide that much gain and bandwidth. So a multi-stage amplifier was born. So to explain you more or to discuss you about more about the multi-stage amplifier.
Now, for you to visualize what we are talking about, I am going to draw the CE multi-stage amplifier. So now, in this cascade multi-stage amplifier, we are now solving for the AB of the two stages. Now, in order for us to get the AB in the stage 1, we would need the R prime E in the stage 2. Now that we have solved the voltage gain in stage 2 and the R prime E of the stage 2, we're now able to take the voltage gain in the part 1 of the or stage 1 of the circuit.
Okay, so now we have the values for the stage 2. Now we can solve for the stage 1. Okay, so now I have written all the solutions for stage 1. In stage 1, we first find the RTH, which is the R1 parallel to R2. Now we find the IB1, which is equals to VTH, which is the voltage divider theorem on RE. So minus that to VBE over the RTH plus beta plus 1 of RE1. To find the RE1, now 26 millivolts over IE. Then we find the IV1, which is RC parallel to RE2 over RE1, R prime E1. Now, you're wondering what is RE2? Now, RE2 is the R3 parallel to R4 parallel to beta RE prime 2. So
Now that we have solved all the DC analysis, including the AV1 and AV2, we're now going to move on to the AC analysis of the multi-stage amplifier.
For the AC analysis part, I will draw first the figure for the multi-stage C amplifier. So, this is the AC equivalent circuit for the multi-stage C amplifier. So now, I will show you how to solve the low frequency response of this circuit. These are the equations for the low frequency response of stage 1 and stage 2. So for FLI1, we use the equation 1 over 2 pi R1 parallel R2 parallel R in base 1 times capacitor 1. For the FLO1, we use the equation 1 over 2 pi RC1 plus R3 parallel R4 parallel R in base 2 times capacitor 3. So for the FL bypass 1, we use the equation 1 over 2 pi RE1 parallel R prime E1 plus RB, which is R1 parallel R2 over beta of the first stage times capacitor 2. So this is for the stage 2. So this is the low frequency response for stage 2. As you can see, for the equation of FLI2, it is the same equation for the FLO1. So because the reason for this is they are connected with each other. So for the FLO2, we use the equation 1 over 2 pi RC2 parallel RO2 plus RL multiplied by capacitor 5. And for the FL bypass 2, we use the equation 1 over 2 pi RE2 parallel R prime E2 plus RB2, which is R3 parallel R4 over beta of 2 of the second stage times capacitor 4. So that's it for the low frequency response of stage 1 and stage 2.
Hello guys, and I will be discussing to you about high frequency response amplifier in stage 1. So, and we will be discussing our formulas for our stage 1 amplifier. Oops. Maya ka na. This 4 or 5 is usually given in terms of the worded problem that you will usually encounter in a book. And in our high frequency response, we will be utilizing the frequency formula 1 over 2 pi RC. And RC will be determined when you use the AC analysis for the high frequency response. And for the R in and R out, for the high input and high output response, you will use this in terms of connection from the input side of the AC. So R1 parallel to R2 parallel to the internal resistance R prime E, which is multiplied to beta. Then for the RO, you will use RC1 parallel to R3 and R4, since the connection from here, the output side of stage 1 is connected in parallel with the R3 and R4, which is the Rin of stage 2. Then, now that you've obtained R1 and Rin and RO, you will get the C total of both input and output, which is equivalent to these formulas that you will use the usually given values. The capacitance wiring output, capacitance in the CE part of the transistor, then the CBC, which is the base collector part of the transistor, multiplied to AV plus 1 over AV from the DC analysis, the voltage gain. Then almost the same process, C in total, CBC times AV plus 1, then add this to capacitance wiring input and the CBE. You will now get both high input and high output frequency response. Dali lang, di ba?
So today I will be discussing the high frequency response for the second stage of the So first thing first, we have to solve for the Miller input and output of the capacitances. So for input, CMI, normally it is for the CBE, for the C total, CBE plus CWE wiring plus the Miller input. For the Miller input, should be the same as the high frequency output of the first stage. Now for your resistance, the total resistance will be the resistance of the collector parallel to the resistance here, which is R4 parallel to R3. Then going down here, parallel to beta to R2. Now this is your total resistance. Now combining all, your final formula for the input high frequency response is RC parallel R4 parallel R3 parallel beta to R2 multiplied by the total resistance that you will get for the input. See total. Now this is your general formula for your input high frequency response. Now going to the output, since you see here that the output is connected here and there is no additional resistances. So the only resistance that you will count is for the collector resistance. Multiplied to the total resistance that you will get used with the mirror output and then the common emitter. Okay, so for FHO, same concept, 1/2 pi RC. Your resistance, since there's only one resistance there, that's only your capacity collector resistance 2 for second stage. Now for your capacitance total, it will be CCE plus your output wiring plus the mirror output capacitance using this formula. Now combining this to get the final formula for output, it's just 1/2 pi RC multiplied by the C